For more similar videos, kindly turn on the notification button and subscribe to my channel. Like and share the videos. Thank you.
In our example today of rate, we want to solve this problem that says a bus left Normal and traveled towards Mobi at 40 km per hour. And after 1 hour, another bus left Normal and headed to Mobi at 50 km per hour. So we have to find how long the first bus had traveled while it was overtaken by the second bus. In this type of problem, it's not what you are asked to find that you need to center more attention on, but what you're going to use to generate what? Your equation. Now, if you underline the word overtaking, if the two of them started from the same place, but not at the same time, though not at the same time, at the point when the faster one is overtaking the slower one, at that point, both of them has covered the same distance. Therefore, to generate our equation, the distance covered by the first bus must be equal to the distance covered by the second bus. That means we generate our equation by saying D1 equals to D2. So the first bus, let me quickly draw this micro table. So we have speed, distance, time. So the first bus, the speed is 40 km per hour, and the second bus, this is the first bus. For the second bus, this is 50 km per hour. Now, since we say D1 will be equal to D2, because at the point of overtaking, both of them must have covered the same distance. But what about their time? Which one has spent more time? If, for example, two people are asked to start exam, and one started 5 minutes earlier than the other, and both of them are asked to stop at the same time. At that point, at that stoppage time, the one that started earlier must have spent that 5 minutes more than the second one. So the same thing here. The first bus has started 1 hour earlier than the second bus. That means at the point of overtaking, if you calculate their time taking, the first bus must have been 1 hour, spent 1 hour more than the second bus. That means if we let our value of t, the second bus, his own time to be t, then the first bus will be t plus 1. So we generate our equation along this. First, we say speed equals to distance over time. Here, the speed for the first bus is 40 equals to, his own distance is d1 over t plus 1. When we cross multiply to make d1 the subject to the formula, we have d1 equals to 40, open parentheses, 1 plus t. So we get value expression for d1. Similarly, d2, if you make the same expression for d2, we have d2 equals to the speed, which is 50 times his own time, which is t. At the point of overtaking, d1 equals d2, which implies that 40 into bracket t plus 1 equals to 50t. And if you open the bracket and solve for the value of t, we have 40t plus 40 equals to 50t. Collecting like terms and simplify, we have 40 equals to 50t minus 40t, which will give us 40 equals to 10t. So to solve for t, we divide both sides by the coefficient of t, which is 10, and that will give us t equals to 4 hours. This 4 hours is for the second bus, but the time for the first bus is also expressed in terms of t. So what we're going to do is to just say time taken by the first bus. That's what we have to find. Time for the first bus is t plus 1, and that will mean 4 plus 1, and we have 5 hours. So this means at the point of overtaking, the first bus has traveled 5 hours.